Oxygen. Oxygen is a highly reactive, colorless, odorless, tasteless substance often found in the form of a gas. An oxygen atom has 8 protons, 8 electrons, and 8 neutrons. It has an atomic number of 8 as it has 8 protons, and an atomic mass of 16 as it has 8 protons and 8 neutrons, both with a mass of approximately 1. Electrons have an insignificant amount of mass, so it is easier to only count the neutrons and protons. The mass of an atom is concentrated in the nucleus, as that is where the protons and neutrons are. The electrons orbit the nucleus in shells. An oxygen atom has the electron configuration 2-6, meaning it has a full inner shell with 2 electrons, and it has a valence shell or outer shell with 6 electrons, and no other electron shells. As protons have a positive charge and electrons have a negative charge, and there are equal amounts of each, the atom has a neutral charge. Neutrons have no charge and do not affect the charge of an atom. Atoms naturally want to have a full valence shell, so metal atoms and non-metal atoms give and take valence electrons respectively. By doing this, the atom's charge changes and creates an ion. Metal atoms become positively charged as they donate electrons and are known as cations, and non-metal atoms become negatively charged as they gain electrons and are known as anions. Isotopes are formed when an atom has a varying amount of neutrons in the nucleus. Examples of oxygen isotopes include oxygen-15, oxygen-16, oxygen-17, and many more. If an atom has too many or too few neutrons, it can become unstable and radioactive. To stabilize itself, it will produce radiation. There are 3 types of radiation: alpha, beta, and gamma. When isotopes decay, they release either alpha or beta radiation, and gamma radiation may be produced because of this. Alpha radiation is produced by an atom projecting a helium nucleus, 2 protons and 2 neutrons, from its own nucleus, changing the element. Beta radiation is produced by a neutron in the atom's nucleus, splitting to form a proton and an electron. The electron is then projected out of the atom altogether. As gamma radiation is a wave and not a particle, it is not produced unless either alpha or beta radiation is produced. Electrons determine the reactivity of an element because they determine how many electrons need to be lost or gained to have a full valence shell. The closer an atom is to having a full valence shell, the more reactive it is. This means that the closer elements are to the middle of the table, the less reactive they are, excluding the last group, which is not reactive at all. Oxygen is in the 3rd last period of the periodic table and is therefore very reactive. Chemical reactions occur due to the magnetic forces of elements. If an atom is imbalanced, it will have either a positive or negative charge, which causes it to be attracted to atoms of the opposite charge, and under the right conditions can cause them to bond together and create a new substance. Another way chemical reactions occur is through covalent bonds. If 2 atoms of the same or similar group of the periodic table both want to gain electrons, they may share valence electrons, also creating bonds between the atoms and creating a new substance. A common chemical reaction involving oxygen is cellular respiration, which occurs when your cells make energy for your body. The word equation for cellular respiration is glucose plus oxygen yields carbon dioxide and water and energy. The balanced chemical equation for cellular respiration is written on the board.